Aaron, where have you been? It's been 3 weeks. People are starting to get worried. Aaron! Oh God, where is he? Oh God. Oh, the coons are back. Time to exterminate.
Hello, and welcome back to the whiteboards. Today we'll be discussing carbohydrates, semi-permeable membranes, and eggs. Yes, eggs. Don't question me. Anyways, a carbohydrate is a large organic compound found in foods and tissues. It is also broken down by animals to produce energy. A semi-permeable membrane allows certain compounds to pass through, mainly water. Osmosis is the net movement of molecules through this membrane, and diffusion is the net movement of molecules from a high concentration solution to a low concentration solution. Now, I'm going to explain how these two factors play into an egg. But first,
Excuse me. So, this is an egg. It has two layers of protection. The shell and the membrane. In this case, we don't care about the shell. We care about the membrane because the membrane is semi-permeable and allows for water to pass through.
Wow, that was pretty weird. Let's go look at some eggs.
Bazinga, and welcome to a new location in which we will be making our bouncy eggs. This takes a very long time, which means we have to start the whole process several days in advance of the actual recording. So to do so, we need to pour vinegar into a batch of eggs, which I have set up here and I'll show you right now. Here we have 2 sets of eggs, which will be dissolving the shell with white vinegar. This whole process takes around 1 day to accomplish, so we'll check back in on our eggs in around 1 day.
I'm high on believing that you're in love with me.
Now that it's 2 days later, you can see that all the shells of our eggs have been removed, leaving us with just the membrane, which creates this really squishy egg that decides to bounce. So the next step of this is we're going to take 8 of these eggs and we're going to put them into separate liquids: peptides, Irish soda, corn syrup, alcohol, motor oil, bouillon cubes, soy sauce, and wine, to see the reaction that happens between the membrane and the liquid. We're then going to finally take the last 10 eggs and put them into these 2 waters for controls. So we'll be back here after 1 day. No, we won't. We'll be somewhere else. That's right. I have no friends.
So it's a day later, we're back in our original location, which means we can check back in on those eggs that we put in to those 8 different solutions. So if you follow me over here, yeah, okay. So we have our 8 solutions: Irish soda, bouillon cubes, alcohol, soy sauce, motor oil, wine, peptides, and cornstarch. As for the alcohol, you can see that the egg looks like a normal egg, right? But it's still squishy. It still bounces. It bounces. So that means that's pretty good. Anyway, moving forward. That looks like a normal sized egg, right? Then we move on to our cornstarch, which mistakes were made. Okay. As you can see, our egg is all like deflated. It's disgusting. Let me wash this off real quick. And I'm just gonna be like, so as you can see, this egg, it's kind of deflated, right? It's not at its purest form. It's just, yeah, and it doesn't bounce, does it? Oh no, it kind of bounces. It just kind of flops there. Yes. So as for our other eggs, it looks like the peptides cause the eggs to be rather bouncy, rather squishy, just, yep, it bounces pretty well. The wine also looks pretty plump. compared to the other eggs so far. I'm not putting my hands in motor oil. Soy sauce. Woo! As you can see, it turned black because the color of the soy sauce got infused into the egg. As for bouillon cubes, there's still bouillon cubes inside my solution. This is also pretty firm of an egg. It doesn't bounce that well, so you don't want to see that. And the Irish soda, which is normally just water with some sugar, also seems to be pretty plump. Anyway, the only thing left to look at is our test eggs, which is our control, which is to say we just put these in water. So, if you want to come and join me again over here. These eggs look rather like water balloons. Oh, this one's warm. As you can see, the yolk is kind of floating. Okay, yeah, it disappeared. Well, the yolk was floating around in here, and you could see it. But as you can see, it's a very greenish color, and it's really plump compared to the other eggs that we have. Same goes for probably the purple eggs. Yeah. But the problem is this wouldn't be a science by default video if something didn't go horribly wrong, or we didn't blow something up, or make a mess of things. So, roll the montage! Oh, wait. I forgot to explain what happened. Well, as you can see in the first part, we added our eggs to the vinegar. When we added the eggs to the vinegar, the calcium carbonate that surrounded our eggs was dissolved by the acidic property of our vinegar, thus revealing the membrane which was explained earlier. Because this membrane is semi-permeable, it allows for the net movement of water through our molecules. So that means if our egg is put into something that has a higher water concentration, that means it's going to flow in and make it plump, as you can tell by our green eggs. But as for the cornstarch eggs, because the water is less on the outside, our egg got really deflated. So yeah, that's what happened. Ooh, bouillon cubes exploded. You think there's anything else, my good sir, that needs to be explained about how these eggs became how they are? No? No? Now roll the montage!
Hey Aaron, how you can get out of there?
There's only one option. I'm sorry, my precious baguette.